This is the main priority. First of all, start the recording. Then make the screen share, and finally I will mute out. Can you see the screen?
Yes, sir.
Yes,
Oh,
sir.
okay. My sound is okay.
Perfect.
Okay, nice. Okay, nice. I am muting for purpose. Please, I am muting all students. So okay, I'm muting all students. You please give your role in the chat box, everyone. Everyone, give your role in the chat box and also your batch, because you have 30 role, batch 30, batch 29. So give your role and also your batch in the chat box. That will help me to find out the attendance. Yes, role in the chat box and batch also. Those two information, both batch and role. Everyone, please, everyone, give your role and batch also. Okay, uh, you can. Okay. So yesterday, we were, studying the topic of clippers. Okay, introduction to clipper circuit. So we saw unbiased clippers. I told you that so there are two types of clippers. When there is an extra DC supply available in the circuit, that is biased clippers. But yesterday we saw there is only one input DC supply and there is no extra DC supply. So that was unbiased clippers. So those was very easy one, and a very basic one. Today will be some of the different one, the biased clippers. The first of all, let's see. Today we will see 2 or 3 examples. Then I will give you the homework. Then you will try by yourself and practice. So basically, the biased clippers is known as the clipper with the DC supply. Okay. Yesterday I also discussed the clipper with a DC supply. Clipper with a DC supply. My students, I have given you already the book. Okay. I have already given you the book. So I'm giving you the class lectures every day, but still if you want to study more, definitely book is the main source. So you can definitely study from the book also. So please use your book also. Okay, let's see this circuit first. See this first circuit first. You can check that there is a DC supply is available here. Okay, there is a DC supply available here, and the diode is also there. This is definitely the ideal diode, my words. And there is a resistance where that is marked as the output VO or VO. The voltage against this resistance is the output, and in the input we can denote as the VI. Okay, so please make you mute if anyone is not muted. Make you mute. Okay, because it will create noise. Okay, uh, so at first you see that this is the input circuit and this is the input voltage. This is the sinusoidal voltage. Okay, sinusoidal voltage is the input voltage. It has both positive cycle and the negative cycle. So we have to find out what will be the output waveform. This is the input waveform. We can see what will be the output waveform. We need to find out. So for that, we have to analyze both for positive cycle and negative cycle. I think someone is creating some noise, so I have to mute him. I think now it's clear. Okay, sorry for the interruption. So we have to, we have to analyze both for positive cycle and negative cycle. Okay, so let's go. Let's go. What is waiting for us? So first of all, we need to calculate for positive cycle. Okay. So the first task will be, listen my words very carefully. This looks like a very simple thing, but very complex. Not very complex, but a little bit complex. How? I'm telling you. So suppose this is the diode. I told you that the first thing you will notice, that is what is the current condition of diode. Is it forward bias or is it reverse bias? You have to find out at first. So if we take the positive cycle at first, so at that time this input will be something like that. This will be plus, this will be minus. Okay, so this will be plus, this will be minus. To check that this P terminal is connected with plus and the N terminal is connected with minus. So from the very beginning we can say that this diode is forward bias. So this diode is forward biased, but it is absolutely true if there is no DC supply. Okay, there is no DC supply. You can, if you just consider this DC supply, just consider this DC supply. At that time, this P will be connected with N, and this will be connected with plus. So basically, at that time, it looks like it is a reverse bias. So you see that this is a contradictory situation happens because of the two voltage supply or the two DC supply. So this is crucial part, that what is the current situation of diode? Is it forward biased or is it reverse biased? So the main thing is that we need to find out for that. Still we are working in positive cycle. We didn't see the negative cycle. We are still in the positive cycle, and the main thing happened. So we need to find out at first that, sir, when it is forward biased, when it is reverse biased. So we have two voltage source. One is input voltage VI and another one is V. Okay, this one. So remember, whichever the value is bigger one, the effect will be on that voltage source. When the VI is the bigger value, then its effect will be applied on diode. When the value of V is bigger, the effect of this voltage source will be applied in the diode. Not clear probably. Suppose this is the positive cycle. You see that this is the positive cycle, VI. So this is the positive cycle. You see that this is the DC voltage. So in the DC voltage, it looks like, suppose this is the value. This is the DC voltage V till this is the DC voltage V. So when the V is VI at 0, at that time definitely the value of V is bigger one. So initially though it is applied as input voltage VI, initially the value VI is less than V. initially Vi is less than V. After some times, check my marking, after some times these two will be equal. When it is both value are equal, after some times the Vi will be greater than V. Okay, this the peak value, you see that the peak value Vm, and definitely the peak value Vm is greater than the DC voltage V, definitely. So you see that the transition happens at first, because at the very beginning, let me draw one more diagram so it will be help you, a bigger one. Suppose this is positive cycle. Okay, this is the V. Everything is same, just follow my process, every mathematics will be same, but the understanding is the very important. The understanding is very important. So this point, at this point the Vi is 0, the input voltage is, this is 0. This point, see that this is the point where the both the value are equal. When the input voltage cross this point, at that time the input voltage is greater than the value of V. So initially this amount of place, the DC voltage is greater than the input voltage. At this point they are equal, but after this point the input voltage is greater than the DC voltage V. So you see that there are two stages. There are two stages, and I told you that when the Vi is greater than the V, the effect will be for Vi. When the V is greater than Vi, the effect will be V. So my main goal was to say that initially the Vi is less than V. So that's why on that time the effect on diode will be for the DC voltage V. So at that time this will be minus, this will be plus. So at that time it will be reverse biased. But when the Vi will be greater than V, at that time it will be forward biased. So that's why it is in the positive cycle, it is not the whole forward biased, not the whole reverse bias. It is divided into two parts. Okay, let's check what is written. You can see that here is written when the Vi is greater than V, the diode is, sorry, when the Vi is less than V, the diode is reverse biased, and when the Vi is greater than V, the diode is forward biased. So we have to first of all check this kind of contradictory situation, that when the diode is forward biased and when the diode is reverse biased. So we have already identified that. Okay, so let's see what is the next. So next is that we have to apply the KVL in this diagram. We have to apply the KVL. If we apply the KVL, this is plus, this is for, we are working still in the positive cycle, my students. I'm going very slowly because you know the understanding is very important for this example. So this is the sign. So if we go for the KVL, if we take the second sign, everyone, this, then it will be plus, it will be minus, and it will be minus. So basically the equation will be Vi minus V minus Vo equals to 0, equals to 0. Okay, so let's see what is the equation written here. It will be same, exactly same. You can see that the equation is also given something like that, Vi minus V minus V0. So The output equation is, we have to find out the output equation. What is the output equation from this KVL? So the output equation is V output equals to VI minus V. The VI minus V. Now we have to find out that what is the output value in these two situations, because we have already find out that in some part this diode is forward biased, in some part the diode is reverse biased. So I already told you that at the very beginning the input voltage Vi is less than V. Okay, so at that time the diode is reverse biased. You see that the diode is reverse biased. So for reverse bias situation, from this KVL we got the output equation. So when suppose, what is the so when the reverse bias situation happens, reverse bias situation happens when the Vi is less than V. Okay, less than V. Vi is less than V. So at the very beginning the value of Vi is 0. So what happens when the value of is 0? Vi is 0. Suppose the Vi is 0. At that time, okay, when the Vi is 0, what will be the output? The output will be also 0. Why? Because this is reverse bias situation. Okay, for the reverse bias situation, when the reverse bias situation happens, the diode becomes, let me go to the diagram so you can. So for the reverse bias situation, so the diode becomes open. The diode becomes open. Okay, so when the diode becomes open, there will be no current flowing. So when there is no current flowing, there is no voltage drop in the resistance. So the voltage, output voltage will be 0. So the output voltage will be 0 on that portion. Okay. So okay. So even when the Vi is equals to V, when the Vi is equals to V, okay, at that time also the V output will be 0, because the, the thing is happening just like that. So at the very beginning it is 0, and this is the point V. So when the Vi is equals to V, at that time from this equation, if I replace the Vi from using V minus V, it will be 0. So from this total portion, from this portion, the output will be 0. Okay, so this is for the reverse bias situation. Both from, okay, there is a question come, sir, as you told us, when the V is greater than Vi, it is reverse in that, while the V is less than Vi, that is forward. So how about when they're equal? Okay, so that is the transition, my students. That is the transition time. When the Vi is equals to V, when the Vi is equals to V, at that time the transition happens. Okay, and that it's not about that that particular point. Amir, yeah, yeah, I'm discussing with that is the situation we are discussing. You see that is the transition, that when the Vi is equals to V, when the Vi is equals to V, when the Vi is equals to V, at that time, if I just input this equation in this output equation, Vi equals to V, at that time also the output is 0, because that is the transition, that is the 0 point, that is the 0 point of the changing diode situation. So when this level is crossed, then the forward bias starts. Okay, so you can see from this this mathematical derivation also, that when the vi equals to v, that is the the middle point, that is the point where the transition will happen. From there on the transition will happen. So this is the reverse bias situation. So for the forward bias situation, this is the starting point. Forward bias means now the input voltage is greater than v. Okay, the input voltage is greater than v. So still we have to, you see that we again put this value, input value vi equals to v, same thing. Because this is that the border, of the two situations. So we have to start from the zero border. So always we will also check what will be the value of this. So when the vi equals to v, the output will be also zero. So that is the point the zero thing happens. So the value will be zero also at the vi equals to v. So when the value will be a little bit longer, a little bit bigger than the v, then the forward bias things happens. So you see that we also check that same thing. So when the maximum value, we know that this is the sinusoidal voltage, so it will have the peak value. The maximum value is vi equals to vm. So at that time it will be v output equals to vm minus v. So this is the situation, this is the value we get from the calculation in the positive cycle. So we have to use these findings, when we draw the output waveform. Okay, so let's go to the negative cycle. My students, this type of problem cannot be cleared by only solving one. You have to practice 2, 3, 4, 5, and after that it will be clear for all. And what will be the negative cycle? Let's uh, clear it all, that what happens in the negative cycle. In the negative cycle, my students, now this will be the minus, this will be the plus. Okay, so for the negative cycle, now the diode is, this is connected in the minus, this is connected in plus. Okay, this is connected in minus, this is connected in plus. And also for this DC, this is connected in minus, this is connected in plus. So what I'm trying to say, that from the very beginning of this negative cycle, from the very beginning, and also for the input voltage and for the DC voltage extra, for both, this diode is reverse biased. You see that from the positive cycle, it has the contradictory, that the DC supply working something like that in one direction, the input voltage is working on another direction. But when it comes to the negative cycle, we can see from this configuration that both the voltage are working against diode. They are making the diode that it remains reverse bias situation. So when the reverse bias situation happens, we know that the diode becomes just like an open circuit, open terminal. So there is no current will be in this circuit. So the voltage, output voltage VO, will be absolutely zero. Okay, so there is no denial, there is no contradiction in the negative cycle. It will be zero from the very beginning to the last end. The output voltage will be zero. Okay, so that is the findings from the negative cycle. It's very crystal clear, we can say. Let's see the, okay, same thing happens. The in the negative cycle, the diode is reverse bias. So we know that in the reverse bias, there is no current. So the output voltage VO is zero, because the output is against the resistance in this circuit. Okay. So let's, whatever we have find out, let's draw the diagram, the waveform. So this is very important. Um, this is, the input is given. Okay, let me make it a bigger one. So we have, it will help us to draw much more bigger one. Okay. Okay, you see that this is the input voltage for the positive cycle. Let's draw for the positive cycle first. This is for the positive cycle, and I told you that this is the V, the DC level V. Okay, and you see that till this point, this vi minus vi equals to v till this point, or finding is something else. So we can draw this line, and this is also the same in the when it goes in the outer side also is also the same. So this is the half cycle. Okay, so till this 2 point there is no output, there is no output, the output is 0, so we have to draw something like that. Okay, there is no output, but when the vi is greater than v, it is forward biased. So forward biased means whatever you are you are giving in the input, it will be in the output. So we are getting the output, we are getting the output, so we can draw the sinusoidal diagram. But the important thing is that the peak value will be not vm, it is not vm anymore, because from the calculation we got it that is vm minus v. Okay, so this is the starting portion, and the end portion of this is 0, because in this two portion the vi is less than v, and when the vi is less than v, the diode becomes reverse biased. When the diode becomes reverse biased, the output voltage vo equals to 0. So we cannot draw the output in this two region, because in this two region you can see that this two region the value v is greater than vi. So for that reason the output is 0. But when the vi is greater than v, when the vi is greater than v, at that time, we get the output, and but the peak value is not vm, the peak value will be the vm minus v. So this is the overall scenario we find out from the, okay, from the our whole analysis. This will be the output for the positive cycle. Okay, so let's check what is in the negative cycle. We already know that in the negative cycle, this is the negative cycle. In the negative cycle, the diode is reverse biased for both two voltage. So when it is reverse biased, there is no voltage, the output is 0. So you can see that the drawing is, the output is 0 in the negative cycle. Okay, so this is the half cycle border. Remind me, this is the half cycle border, and why this small portion is 0? Because of in this two small portion you can see that this is the point, this point and this point. You can check that this from the below this point the vi is less than v. So when vi is less than v, the diode is reverse biased. We already discussed, when it is reverse biased the output is something like 0, same as the negative cycle. So that's how the whole analysis works on. So I discussed this only one problem for more than 25 minutes. Okay, so I think that there should not be any question, but still there may have some questions. So I will unmute all my students and and ask you that if you have any confusion, so that I can clear. Uh, you can unmute by yourself. You can unmute by yourself and ask me the question, so that I can give you some explanation about your question. Anyone?
So for me, I don't have any question. I got properly.
Sorry, Amit?
I don't have any questions, sir. I got it properly.
Okay.
Thank
Okay.
you.
Okay. Let me unmute my other students. So, is there any question, my students?
No, sir.
No, sir.
Is
All
it
received,
clear?
sir. Yes,
Is
it is
it clear?
clear.
Yeah.
Okay. Okay. Alhamdulillah. It is. The thinking should be something like that. Okay. It is not so tough. I will say it's not so tough, but a little bit complex. So that we have to we have to think. The answer is not so big, but we have to think. Uh, and the interesting part is that it cannot be cleared fully when you see that when you go for the solving purpose. when you have the question and you think by yourself at that time, it will make you much more clear. So I give you one more example. I hope that that give you helps. This one will be very easy. The we discussed in the the for the sinusoidal wave, but when it is a square wave, there is no way for the reverse bias and the forward bias, those the dilemma that cannot happen. So this I have already solved here. Okay, so this will be your home task. It's a very easy one, so I will not discuss and not waste time by discussing this. I'll better discuss one more. I will better discuss one more and you know give you much more complexity to think. Okay, so I am discussing this one with the value. The previous one was not with the value, this one is the value. So this will much more help you to find out overall scenario. Let me see you the output diagram. At first it looks like a messy thing, but not tough. We have to just think step by step. Okay, so at first you see that this is absolutely biased clippers because we have a DC supply with our input AC voltage. So absolutely this is a biased clippers from the very beginning, we can say. And the input voltage is given here, where the right now we can see that the value is given 20-volt peak. Okay, 20-volt peak. This will be, there will be a minus in front of here, 20-volt peak here. So at first we just check the situation of a diode. What is the current situation of diode? So let's check it out. That at first we'll definitely go for the positive cycle. So when it is the positive cycle, suppose something like that, it will be like that. And if you just go for that, this for this positive voltage, this P is plus and this N is minus. And similarly for the DC voltage, you can say that the P is plus and the N is minus. So for both AC voltage and DC voltage, this diode is, for both AC voltage and DC voltage, this diode is
Forward bias.
forward biased. Yes, that is the answer I was expecting. This is forward bias. So there is no dilemma. There is no dilemma just now, like the previous example. So you have to check, just the example looks like the same, just like same like the previous one, but you know that just one sign is changed, it's totally different, everything will be different. So this is forward biased. So when it is forward biased, we all know that when it is forward biased, we all know that the current will go, and this, as it is ideal diode, this will be just like a shorted line. So the we will get the current will flow in this resistance also, and we will get the output in the resistance, and this is our output voltage that is denoted. So at the very beginning we can definitely apply the KVL. When you will apply the KVL, it will be plus VI plus 5 volt and minus V output. Let's see what is written here. Let me, okay, yes, basically it is the KVL. The KVL is given. So if we just apply the KVL, definitely the output voltage will be 25 volt. The output voltage will be 25 volt. That means that is the peak voltage. That is the peak voltage, because if you consider the 20 volt, that is the peak voltage. That is the peak voltage in the positive cycle. But what is because we have also have to find out the starting point. At starting point, the VI is 0. The VI is 0. So at that time, it will be the KVL will be 0 plus 5 minus V naught. So the starting point will be 5 volt, my student. Right now, the output cannot start from 0, because when the start input is 0, the output is 5 volt. So that is the change I need to make in this example. Okay, so this is for positive cycle. This is for positive cycle, and let's go for the negative cycle. What happens? in the negative cycle it will create some problems. How? So now, so this is negative, this is positive. So for that, this is negative, this is positive. So now the diode is reverse bias. But for the DC voltage, this is positive, this is negative. The diode is forward bias. So the dilemma comes in the negative cycle right now in this example. So when it will be the negative, when it will be the positive. Okay. So basically now you just need to draw a 5-volt line in the 5-volt line in the negative cycle. You see that this point, when it crosses this point, and when it crosses this point, so basically this particular time, okay, this zone, it will act as reverse biased. But these two small zone for the DC supply, it will act as forward bias. Okay, so you know that this dilemma happens in this example also. So let's check it out, that how we find out the value. Just the same. The it's written that, you see that it is written that when the V is greater than VI, that I did forward bias, I already discussed that, something like that. So this is the particular point. If it is the V line, if is so this is the particular point, this one and this one for both sides. Okay, so when the VI, because this is the input voltage VI, when the VI is less than V, suppose in this region, both in this region and in this region, in these two region, so when the voltage is less than V, the diode is forward bias. So the diode is forward bias in this two small region, and when the VI is greater than V, the diode is reverse bias, something like that. In this whole big portion, the diode is reverse biased. So we can easily know that. So when forward biased, what happens? When forward biased, at the very beginning, this is the output equation. If we just apply the KVL, we get the output equation. But at this time, you have to take the negative, the positive, negative at first and the positive at first in the circuit. You'll get this output equation: V output equals to minus VI plus V. So when forward biased, that means in this portion, let me draw one more time. This is the V portion. So at the starting point, the VI is 0, and this is the terminal point, the VI equals to V. Okay, so we have to check in this region, to check this region. Okay, to check this region, we have to put this two border value. Okay, so when the VI is 0, the output is V. So in the negative cycle, the starting point will be V. Okay, and when the VI is V, if we put this value, VI is V minus V plus V, okay, minus V plus V, the output will be 0. So the starting of the negative cycle will be V, and the starting of this portion will be 0. Okay, so this is for the forward bias. And whatever the reverse bias, we all know that when the reverse bias happens, the output will be 0. So for this two region, for this whole region, big region, the output will be 0. Okay, so let's go to the drawing directly. So you see that it is written that when the reverse bias, the output will be 0. So if we just go the output diagram, it will give us much more clear idea. You see that this is the positive cycle. We all know this is the positive cycle. So now I already told that the starting point will be 5 volt. This is the starting 5 volt, and this is the, this is the portion of. So this is the positive cycle output. But now the peak value is not 20 volt. We have already find out it is value of 25 volt. Okay, the peak value is 25 volt, and it is not finished in the 0. It is finished at the 5 volt. And in the negative cycle, this small portion is forward biased, and this small portion is forward biased. Okay, so in this small portion, the voltage will be something like that. But in the negative, in the middle portion, it is the reverse bias. That's why it is output is 0. Okay, so I am drawing one more time in the negative cycle, because that will help you. Suppose this is the negative cycle. This is the negative cycle, and negative cycle. Okay, let me give you the make it the positive cycle. This is the positive cycle finished at 5 volt. Okay, so this is the 5 volt line. The positive cycle finished at the 5 volt. And we also discussed that when the negative cycle is 0, the negative output will be start from 5 volt. Okay, so suppose this is the V line. Now till this, it is the forward bias, and it is the forward bias till this. Okay, so till this we get the value. So this is the output, and similarly this will be the output. But in middle, in this portion, this is the reverse bias, so that's why there is no output. That's why it is 0. So basically, in the negative cycle, we get the output something like that. Okay, something like that. Is there any question? Let me check it out. Probably there is one question. No, it's not question, just the roll number. Okay, so that is the looks like the negative cycle, that is output. So this is these two portion, this portion and this portion, these two portion are forward bias. That's why we get, but it should be like this. Okay, in the negative cycle, but this portion is cut out. This portion is cut out because in this portion it is a reverse bias. So I think you understand. So it looks like a critical situation, but if you go if you apply the findings step by step, you will get the proper waveform from this type of diagram. So I am that's it for today, because I will not make you tougher, because if I discuss so many things to one day, you will be get confused. So I am unmuting all my students. If there are any questions regarding this type of example, you can ask. Everyone is unmuted. My students?
Yes, sir.
Is there any question? Okay. So I will give this slide, this lecture, as soon as I finish the classes, and I will also upload this video lecture. And I saw that there are so many students in the class, but when I upload the video in the YouTube, I saw only 5 or 6 views, and that means I can also see the how much you go to the video lecture. So I saw that there is hardly any students watch the full video, but still I am uploading daily to day video regularly. So if you don't have any interest, I will definitely, I can delay the upload, but I upload immediately because of you, that you can study. But I hardly saw any students study using video lecture. Is it true?
Sir, no, maybe some students don't like to watch the video, the back to video. Just that it doesn't matter. But there is some students those interested to watch the video. That's
Yes.
the deal, sir.
Yeah, because if you miss the class, you definitely need to saw the video.
Exactly.
Because as far as I'm concerned, I discussed thoroughly in the video. Okay, in the book also, when you see the book, you will not find this kind of explanation, because I have studied the book, I have analyzed that, and then I made my hand note type. This, you can see that everything is hand note type, so we can understand step by step. So if you don't, if you just see the lecture, it can help, but still, when you see the video with the lecture, it will definitely help you. It looks like a class, looks
Yes,
like a class. So try to see the video also. So
inshallah.
okay, in this lecture there are two more example that is done by me. Totally five, I have discussed two, but three. So you will solve by yourself. In the next class I will discuss and I will ask why this is, I will just cross check if my students studied, why this is like that, and you have to give the viva, just like viva. I will ask that why this waveform is like that, why this waveform is like that, what will be the waveform of this. So I will ask. So this is a very hard task. Today is Sunday. The next class is our Thursday. Thursday. So you have 3 days or 4 days. So you study this slide properly. Okay.
Okay, sir.
Okay,
Okay.
sir.
Okay, sir. I will finish this class here. Today we got only 13 students. Can I talk with Hasnat? Hasnat,
জি স্যার, সালাম আলাইকুম স্যার।
walaikum salam. What about other students?
স্যার সবাই তো মনে হয় গ্রামে ব্যস্ত স্যার, কেউ এখন গ্রুপে ওরকম অ্যাক্টিভ নাই।
গ্রামে কি করে?
এই স্যার ঘোরাফেরা আর কি।
গ্রামে ঘোরাফেরা করে। তোমাদের কোঅর্ডিনেটর কে?
জি স্যার।
তোমাদের কোঅর্ডিনেটর স্যার কে?
তাপসির স্যার।
ওকে, তাহলে আমি স্যারকে জানাই তোমাদের বাঙালিরা এবার ঘোরাফেরা করতেছো।
ঘোরাফেরা বলতে স্যার অ্যাক্টিভ না আর কি ক্লাসে।
সেটাই তো বলতেছি। অন্যান্য ক্লাসও সেম?
জি
আমার
স্যার।
ক্লাসে?
না না, অন্যান্য সব মিলিয়ে একটু ইনঅ্যাক্টিভ স্যার।
তো এই দিন অ্যাক্টিভ হইলে তো আমাদের সামনে তো মিড টার্ম এক্সাম হইতে পারে। তো তোমরা তো এইভাবে যদি ক্লাসে না আসো, তাহলে তো এইভাবে তো সিকোয়েন্স ওয়াইজ বুঝবা না তো।
জি স্যার।
ঠিক আছে, এটা জানাও, ওদের জানাও, আমার কথা বলো। ঠিক আছে।
জি
ওকে মাই স্টুডেন্টস,
আজকে আবার বলে দেবো স্যার।
everyone got give your roll and batch, everyone. Okay. Okay, I'm ending this video here. So